Alright, so what we're going to be doing today is talking about area of circles and seeing how it relates to what we've done before. First off, how are circles different than the shapes we've already been practicing? Well, the first way they're different is that circles can have different types of areas. The one you're probably most familiar with is the full circle. So that formula, if you don't remember, is pi times radius squared. Okay, and that's a very common formula. You probably practiced it all the way back from a couple years ago. Looking at a specific example, if you're given the radius, which is halfway across the circle, you simply take that 5 in this example and you plug it into the actual formula itself. So I replace r with a 5. 5 times 5 is 25. So 25 times pi units squared. Sometimes you'll use 3.14 for pi, but in my class, please use the exact pi. Unless you're talking about something where you're actually calculating it for like a company or something, in which case they would probably want to know the exact square footage. Right off the bat, we're just going to go ahead and try a couple of them. So you're going to use the formula pi times radius squared. Pause the video, give it a shot. It should only take you about 30 seconds. Alright, so you're going to plug in 7 for the radius because it's halfway across the circle. 7 times 7 is 49 pi centimeters squared. Notice I use centimeters squared because in the original problem they gave me centimeters. Alright, let's try another one. Be very careful on this one. It's a little bit trickier, making sure you know what the radius is. And hit play when you're done. Alright, so the radius on this one was 9. That's what you had to be careful about. If you put 18 in there, you'd get it wrong because when we talk about a circle, we're only talking about the radius being halfway across. So then in that case, it's 9 and 9. 9 times 9 is 81. So the answer is 81 pi inches squared. Alright, so a couple other ways that we sometimes look at circles is you'll be given half of a circle. The formula for that is we simply take the formula of the area, pi times radius squared, but we cut it in half or multiply it by a half at the end. The same thing is true if we're given something like a quarter of a circle. We go, oh, a quarter is 1/4 of a circle, so we're going to take the area of a circle and times it by 1/4. The question is, what if the piece that I'm given, one of those little sections like that, what if that is not a part I know? It's not a fourth, it's not a half, it's not a third, it's something odd that I can't look at and just know. Well, something like this, like 30 degrees. So if I have a little 30-degree chunk, but I don't know how much it is, how can I calculate the area of that? How can I figure out the formula I would use? Well, that first of all is called a sector. And anytime you want to find the area of a sector, you're going to use the formula for the area of a circle, which is pi times radius squared, but you're going to figure out what fraction of the whole circle that little chunk is, just like we did with a half, just like we did with a fourth. Well, the first thing to think about is how many degrees are in a full circle. Hopefully you're thinking of 360. If you can't remember it, every time you do a 360 is when you spin in a full circle. They do that in a lot of different sports. So now what we're going to do is we're going to set up basically the fraction like before, but what we're going to do to figure out what that fraction is we're going to use two pieces. We're going to say, all right, what are the degrees of my sector? 30. What are the degrees in a whole circle? 360. That now is my fraction. However, usually you can simplify that fraction. For me, when I want to simplify the fraction, the first thing I do is I get rid of both zeros. Then I look at 3 over 36 and I simplify that by dividing by 3, and I'm going to get 1 on top and 12 on the bottom. Now, depending on any area I have, all I have to do is plug in the area and then divide by 12 at the end. So on this time, I'm going to go ahead and I'm going to give you a problem, and the first thing I want you to do is I want you to go ahead and set up the formula, so figure out what the fraction is, and then after you do that, plug that 6 in there for the radius and see if you can get the final answer. So remember, you're going to follow that method of having sector on top, whole circle on the bottom, and then pi times radius squared. So hit pause, play when you're ready. Alright, so hopefully you realize it's going to be 60 on top because that's a sector over 360. Simplifying 60 over 360 gives you 1/6. Now we're going to plug in our 6. 6 times 6 is 36. And 36 divided by 6 is 6 pi centimeters squared. Some people get confused on the way to do that step right there. The thing to remember here is that when I multiply 36, that's like 36 over 1. So I can then multiply straight across, and I get 36 on top and 6 on the bottom. Go ahead now and try it on this one as well. Remember, use your setup of sector over whole circle. See if you can come up with a fraction that represents of the whole thing, and then multiply it with the radius included. All right, so we should have put 45 on top and 360 on the bottom. Now we simplify that fraction and get 1 over 8. Plugging in my radius, I'm going to end up with 16, 4 times 4, and then I times that by 1/8. Simplify 16 over 8, I get 2 pi inches squared. Again, remember, inches came from the fact that I started off with inches. It's not random. All right, the last thing we're going to talk about as far as the area of a circle is a piece that we call a segment. What happens is if you take a line and you connect it to two sides of a circle, not including just the center, so any line that connects the sides of a circle is called a chord. So I could draw a whole bunch of chords on here. I could draw chords anywhere. Okay, I could draw them all over. And what you may be thinking is, isn't a diameter then a chord? Yes, it is. Diameter is a special chord that cuts it directly in half. Now, in this area right here, this sort of area right here, if you then fill in that area, that is called a segment of the circle. From there, then, we would be able to figure out a formula. Now, for now, we don't really have all the tools we need, but if you want to think about it in a simple way, if you were to put a dot in the center and you were to connect the edges of it, really what you'd have, if you filled this in, would be altogether one big sector. If you think about it, that's a whole sector of a circle now. So if we were to find the area of the sector and then subtract the area of the triangle we just drew, we'd be left with the segment and we'd be good. But we do need some tools to be able to do that, because even though we know this is the radius, we don't really know what the base is, and we don't really know what the height is of this triangle. So now what we're going to do is we're going to apply what we had done in class yesterday and the day before, where we were given a random shape, but this time it's going to include circles. Before it was just trapezoids, rectangles, triangles, and parallelograms. Now it includes everything. So the first thing we're going to do is we're going to need to, just like before, figure out how can we break this up. Alright, so the first thing I'm going to do on this one is I'm going to try to break it up. When I try to break it up, the first thing you should notice is that you have half a circle right there. That means the formula for that is going to be 1/2 pi times radius squared. So now you have to ask yourself, what is my radius? Well, my radius is halfway across the circle. However, this 6 that it gave me is the whole way, so each half would only be 3. So from there then, I can go ahead and say 1/2 pi times 3 squared. Simplifying that, I'm going to end up with 9 over 2 pi. I can include units squared on there, but it's 9 over 2 pi. And that's my first section. Second thing I'm going to do is I need to draw a line in here to kind of break it up a second time. So when I do that, what I'm going to do is I'm going to go ahead and draw a line straight across right here. Ooh, maybe better than that. Straight across. And what that does is it breaks it up into a rectangle right here and a third section right here. Okay, so now I'm going to go ahead and work on my rectangle. My rectangle is going to be base 1 plus base 2 times height over 2. That's the formula. Okay, so using that, I've got that the base of my triangle is 6. That came from the fact that I knew this part right here was 6. My other base is also 6 because it's a rectangle. My height is the 9 right there. So that's 9 and all over 2. This is going to equal 12. And 12 divided by 2 is going to give me 6. 6 times 9 equals 54. Okay, now I'm going to move on to my third section. What I want to identify on that is I've got this base here, and this height here. So first off, my height is 3. I got that because the whole thing is 12, and I'm subtracting away 9. Okay, next what I'm going to do is I need to know this base is 10 here, but what's this other base up top? Well, if this is 6, and then I'm going to add 8 to it, that means the whole thing would be 14. So now my third section goes like this. Base 1 plus base 2 times my height, all divided by 2. Okay, adding this up, I get 24. 24 divided by 2 is 12 times 3, and 12 times 3 is 36. The last step, as you guys know, is to go ahead and add up all the pieces. So I'm going to get 54 plus 36, which is 90, plus 9 over 2 pi units squared. And you'll notice you end up with pi and numbers. You can't avoid that. When some of them are rectangles and some of them are circles, you're going to have pi in some and you're not in others. Okay, the last example, again, we're going to do this together. What I have here is I have 3 different sections. I have one circle, I have a second circle, and I have a third circle. And my last section that's left over, I have basically what amounts to a triangle, sort of right there. Okay, so we're going to go ahead and look at each of those sections. So starting off with the circle, the good thing is since all the circles seem to be the same, we can just say that we have 3 of them, 3 times the half circle. The formula for a half circle is 1/2 pi times the radius squared. So all I have to do is figure out what's my radius. Well, the whole distance across is 4. I know it kind of looks like it's half, but unless it's marked, it's the whole distance across. So the radius is 2. So that means I'm going to end up with 3 times 2 pi. Why? Because I'm going to have 4. 4 cut in half is 2. That makes a total of 6 pi. Now I'm going to move on down to my blue section, which is the triangle. My height is not quite 10 because you have to remember I have a radius of 2 right there. So really my height for the triangle is 8. 10 minus 2. Okay, my base is all 3 of these circles together. 4 plus 4 plus 4 is 12. And then remember, base 2 on a triangle is 0. So now my formula says I'm going to have base 1 plus base 2 times height divided by 2. That simplifies out and makes 4. 4 times 12 is 48. And my final answer is going to be 48 plus 6 pi units squared. So now go ahead and fill out the form. If you want to rewatch any of these sections, that's great. And tomorrow in class, we'll be practicing problems like this.